Hey guys, thanks for stopping by today. Today I want to talk about duplicating pieces. Most of what I do is kind of free form and one off. So I'll make a piece and then I might copy that in a similar manner for another project or even in that same project. Like I make tack boards and tack pieces so that it's a two-player game. One side will have one color piece, one side will have the other. And while I do want there to be some nice tie-in in design and overall kind of feel and aesthetic, I don't normally care if they are exact duplicates of each other. But maybe that's not your situation. Maybe you want to turn pieces on the lathe and make those exact copies of one another. And so, with some technology at our disposal these days, I'm going to kind of go through some steps that I took on a recent project to be able to do just that, to make repeatable projects on the lathe without wasting too much material or time. So normally what I do, since I do kind of one-off projects, is I would kind of freehand turn the first piece. And then if I wanted to make a copy of that, I'd get like a set of calipers and my pencil, and I just kind of see what size I made each of these little coves on here, or beads, or grooves, whatever you want to call them, whatever the proper wood turning terms are. I would measure those and then copy them onto the next piece of wood, usually in a contrasting color, because, like I said, I'm doing, um, one in one color and one in another, either color or type or pattern of wood, for some differentiation there. All right, so that is the way that I would do it if I'm just going to free form the first one, freehand the first one, and then kind of try and copy it in a similar, if not exact manner. But if you're trying to duplicate something exactly, and maybe you don't want to freehand the first one, maybe you want more of a concrete design, and that becomes more important the more expensive material that you're working in. So if you have a very expensive burl or a piece of wood that you have a limited quantity in, might want to start on the computer, and that's exactly what we're going to do. So let's get out of the cold garage, go into the house, and get on the computer, and we will mock up a capstone. And with that mock up of the capstone, mock up the jig, and then I'll show you how you would use that in practice on the lathe. Thanks.
All right, so here we are inside, and I'm going to use a couple free programs here to kind of walk through how I would mock up a capstone virtually so that we don't waste wood just kind of freehanding it outside and not ending up liking the shape. So we're going to use FreeCAD for this part, and then to cut our actual template, I'm going to switch over to Inkscape, which is a 2D vector drawing program, and we will make our template out of that so that I can then cut it out on the laser. Alright, so I've got FreeCAD open here, and then we're going to go to the part design workbench, create a body, create a sketch. Let's do it on the YZ plane. And we're going to make our cylinder kind of mimicking what you would end up with after you've used your gouge to kind of get your block of wood into a cylinder shape. So circle tool, do it at the origin. That's just what I normally like to do. And then we will constrain the diameter of this. Let's go with 20 millimeters. Close that sketch. And then we're going to extrude that, or pad it is what they call it. In this case, we're going to pad that out to, I don't know, let's say 50 millimeters. All right. And so this is what you would have on the lathe after you've taken your square block of whatever wood of your choice and gotten it down to the circular shape, the cylinder shape. All right, so next we're going to come up here and we will start another sketch. We're going to do it on the XZ plane, XZ plane, depending on where you're from. And then we're going to use this to kind of mark out what our tool path is going to be for our different lathe tools. If you have carbide turning tools, then what you could actually do is come in here and let's say you have a carbide turning tool that's, X diameter this way, you could just make something that shape and then line it up there, and then you could do another one down here, or if you had a kind of a square tipped one, you would make that whatever size you wanted for that, and then kind of move it over into your blank canvas here. And then what that would do is once you close it, you could revolve that around, and you would see what kind of shapes you would make with your carbide tools there. Okay, let's go back into that sketch and kind of forget that we did all this. All right, so here we are back into our blank sketch, and what we're going to do is we will just start with a square. And we're going to take off this side because otherwise we would just end up with nothing when we revolve it. Let's add a couple lines back to this. Do one there and then one up top here. Let's make sure that one is vertical. This one should be vertical since I followed that line, but we're just going to add a couple constraints here, and that's the basis of FreeCAD. You draw these 2D sketches and then either extrude them or pocket them, use these sketches as tools to make your 3D object. This square is going to represent our template when we're done, and then to add what we're actually cutting into the capstone, let's just grab a B-spline here. Actually, I need to come back out. So we don't want to cut from there. Let's make those 2 points coincident. Come back out here. Maybe we'll want to leave a little bit of a foot on the capstone here, so we can do that by adding a couple more lines here. And we'll come up, I don't know, we'll just eyeball it. You can of course spend as much or as little time on this as you would like. I'm going to constrain those just to make sure that they're square. And then let's go up to our B-spline here, and we will start kind of building what our capstone shape will look like. We're just going to do some random lines here. Let's angle that one back out a little bit, and we'll come in, make a couple little coves there, and then just come back out straight to that, and we'll see what that looks like. And then these are not going to be automatically coincident, so let me adjust those. That way we have a closed shape once we're done with this. Check that one, that's probably not coincident either. And then move those back up into position. Can't see what I've done up here. Alright, so I may have missed some, and we will see if we have a closed shape when we're done with this. But now what you can do is you can play around with your shape here of what your cutout is going to be for your capstone. So if you don't want to come in quite as skinny here, pull some of these spline handles out and just kind of adjust your shape to what you like. To preview what this is going to look like, I'm going to close this sketch here, and I'm going to use that sketch to revolve around the center. Vertical sketch axis, yeah, 360 degrees. We're going to go all the way around because it's a lathe. It just spins. Okay. And then this is what our capstone would look like. If you don't like how that looks, then you can always go back into your sketch Let's make the model visible. That way we can see what we're modifying. And then you can come in here and pull any of these spline handles kind of in or out, and adjust if you wanted that bead to be a little bigger and this to come out further. And you can play with all those. Let's make that a little steeper. Let's not come out quite as far on that one. Maybe something like that. And then if you close that sketch, you've got your new one here. Okay, so once you're done playing around with how your capstone looks and you get something that you're happy with, then what we're going to do is we don't really care about making this. We could 3D print it. I mean, you have an STL that you're building right here, so you could always just put that in your slicer software, print it out, and see how it physically feels, and if it's something that you're happy with there. I always like to prototype as quickly as possible, especially if I'm going to be using some expensive material like some exotic hardwood for this. Then I would want to mock this up first in something cheaper to make sure that the proportions and the hand feel are what I'm going for, because it's really kind of disappointing when you make something and then you get it finished product in your hand and you're like, ooh, I really wish that this had been wider, or this grip groove here really needs to be up higher, or something like that. So getting a physical product into your hand as quickly as possible is I mean, it can't be overstated in my opinion. And that's something that these newer tools, 3D printers, have come such a long way. And modeling software like this, especially free modeling software like FreeCAD, you can really knock something like this out in a matter of minutes, and then have the printer print it, and you can just do 10% infill and fast settings, and you can have something in your hands, and from nothing to play testing with it in a couple hours. All right, but as I said, we don't care about this right now. So what we care about is going to be this sketch here that we've made. That's going to become our template. And so what we're going to do is click off this. Let me create another body here. And I should be able to duplicate our sketch down into this body. Let me go ahead and hide that first body. Alright, I duplicated the sketch down here. And now to make that a physical object, I'm going to pad it. Let's go symmetric to plane. We probably don't need it 10 mil. So we're just going to do a 5 mil pad on this, or extrude on this. And then now you're going to have something like this. I'm actually going to be cutting this out of 3mm MDF on the laser, so we could always just adjust that just to straight up 3 mil to have it mimic what I'm actually going to have in my hand. Something that I do want to add to this, and this is, you can use a set of calipers to do this, but if you remember our original cylinder size, we did a 20mm for the diameter. And so when you're roughing down your material to the size you get it before you start shaping, we want, or I want on the template, something built in that's going to show me that size. So I'll click on that face here. See, I'm under face tools here. I'm going to create a sketch on that face. And then I will make a square back here. And then we'll constrain probably this dimension here. Constrain that dimension. Yeah, I eyeballed it pretty close to 20 mil. And that way, close out of here. I'm going to turn that sketch into a pocket. Let's make sure it goes all the way through, and it does. And so now, when we take this to the lathe, instead of having to set our calipers at 20 mil, we already have a 20 mil caliper or a 20 mil measurement set here in the back of our template for use with that. You don't have to cut this out of MDF if you don't have a laser. You could Again, we're building STLs in this, so you could always export this body as an STL, and then you can print this, 3D print it. You can take it and screenshot it and scale it how you need it to, print it out, cut it out manually by hand on something and use it that way. But what we're going to do is bring this over into Inkscape, and that way I can have a 2D file, 2D vector drawing for the laser to follow pathwise. Alright, so what I'm going to do here is I'm going to screenshot it. So I'm just going to take a snip, and then we will switch over to Inkscape here. Alright, so I just pasted that directly into Inkscape here. For this, I'm going to trace bitmap. I see the tool is already up here. I can go ahead and X that out. But to find it, go up to Path, Trace Bitmap. It's going to give you a preview of it here, and then you can kind of adjust your threshold so that you just get the outline. I've got live updates turned on. You want to make sure that's on so you can see what your changes are here that you're doing. I'm going to apply that. Looks like nothing happened, but it made a copy of that over here. Okay, so to size this correctly, scale this correctly, we're going to get our rectangle tool, draw a rectangle on here, and then we're going to adjust that. Let's make sure the height is really what we care about, because that's going to be this distance here. We're going to change that to 20. And then what we need to do is scale this down. Once we have that at 20 mil, then we know that this is to scale for what we wanted. And then we can just take this and we can export it out as an SVG so that the laser can read it. Pull it into Lightburn or Luban or whatever software you're using for your laser, and then cut that out, and then it will look something like this. I know what I'm showing is not the same template because this is the one that I actually used for my project, and what we did over the past 10 minutes or so was just kind of a mock-up going through the steps. And then once you have your template cut out, you can continue your project using that template to make as many of these on the lathe as you want. And I'll walk you through my process here for that.
All right, I really want to thank you guys for watching today. And if you want to support me further, you can buy my books, look at my Patreon. But really, I just want you to take away from this that go ahead and just get out there and start working. Just start your project that you've been wanting to do, figure it out along the way, use the tools you have to make the tools you need, and make gradual improvements in your crafting game. If you want to support us, yeah, let's go with us. If you want to support the tech community as a whole, come join the Discord. I'll put a link down in the description, and I hope to see you guys there. I'll leave you, as always, with pictures of our project from today. Thanks.